We are going to talk about PolyBase. So, good evening. My name is Kevin Fiesel. I had to test my pointy and clicky thing. It works. We're going to talk PolyBase. I'm a data platform MVP. I run a predictive analytics team located approximately right here. I also have a blog called Curated SQL. The idea of Curated SQL is that I want to try to find and link to 5 to 10 interesting posts per day, somewhere on a topic like database administration or development, R, Python, Hadoop, Kafka, Spark, Power BI, reporting services, security, or anything else in that broad data platform space. So that's curatedsql.com. What I want to do tonight is give you an overview of PolyBase, starting a little bit historical, coming into the present with SQL Server 2019, explaining how it works, explaining how we can use this for data virtualization, how we can scale out queries with this tool. We'll look a little bit at installation and configuration because this is a database administrative group. Most of my talk will be on practical business scenarios, so aiming a little bit more at the developer space. Any questions at all, shout them out. I will repeat them for the people who are remote, and I'm happy to take questions at any point in time, but I'm probably not going to stop and ask for them. So just shout them out, it's fine. With that, let's talk about what PolyBase is. This is Microsoft's technology for data virtualization. It covers 3 specific use cases, one of which is the concept of data virtualization. It's creating this appearance of your data being in one central data store, when in reality it's actually living among several data stores. Those data stores may be heterogeneous. I may have an Oracle server, a DB2 server, SQL Server, and a Spark cluster. And I want to treat them all as though it were really just one central data source, because then I can write queries in one language. I can join tables between these systems without having to think through the mechanics of transferring data from one to the other and building processes and trying to figure out when that process breaks, why it broke, etc. There's also a concept of scale out versus massive parallel processing. So scale out versus scale up, MPP. I'll cover those in just a moment. But before that, we're going to talk a little bit about history. PolyBase is a Microsoft research project. First came out 2012 as part of Parallel Data Warehouse Edition of SQL Server. Parallel Data Warehouse, also known as Extremely Expensive Edition, versus Enterprise Edition, which is merely expensive. Parallel Data Warehouse is an appliance version of SQL Server, and by 2012, they said, hey, we want to solve this use case where I have data that's stored in Hadoop, in the Hadoop distributed file system. I want to bring it over and work with it in SQL Server. And that's what the PolyBase project was all about. With SQL Server 2016, we got that functionality brought into Expensive Edition. In SQL Server 2019, we're getting it along with a lot more. So we have V2. There's a lot more added to this. It's not just Hadoop. There are other sources as well. V1 sources, Hadoop is technically the only source. But it turns out that Azure Blob Storage exposes through an interface called WebHDFS. So it's on a port using this protocol, which is the protocol that we use to connect to a Hadoop cluster and query data from HDFS. That potentially convenient coincidence or action that they did on purpose, I'm not actually sure which, but what it allows us to do is use the same code, the same functionality to connect to either a Hadoop cluster or to Azure Blob Storage. That was all we could do in the original version. There's a side note here that I could get into about Azure SQL Data Warehouse. I'm not getting into that tonight. The version of PolyBase and Azure SQL Data Warehouse is a bit more than V1, a bit less than V2, but it has some special stuff that's not in either version on-prem. Yes?
Did they buy that, or did they make it from scratch?
So the question is, did Microsoft buy PolyBase, or did they make it from scratch? The answer is, it depends, because this version right here This came from Microsoft Research, Jim Gray Labs. This was Dr. DeWitt and Rimaneme and crew. There were a group of people who did this research up in Wisconsin and in Boston and in Redmond and proofed this out, built it into the product. This was all internally built. This version, V2, a little bit different. Here, there was a company, a small company, I want to say it was an Israeli company. Microsoft bought them a few years back. You can see a couple of articles in Google where if you know the company's name, you can type their name in and you'll see Microsoft bought this company and they provide data virtualization software. A couple years later, data virtualization software lands in SQL Server. I'll let you decide whether that was coincidence, whether it was bought or not. But V2 opens the door to a lot more in terms of data sources. So we can connect now to SQL Server. Like getting rid of linked servers, I'm okay with that. Oracle, getting rid of linked servers, yeah. MongoDB and Cosmos DB. Teradata, those are the 4 that are built in. Technically, Cosmos isn't built in. Cosmos takes advantage of the fact that there's a MongoDB adapter, and Cosmos DB's Mongo API is Mongo native. So we can connect to Cosmos DB. It's technically not intended, but it's supported. In addition, any ODBC connector that you have, if you've got an ODBC driver, you can connect like Apache Hive or Apache Spark. You can connect DB2. If you're going for really big data solutions, you can even do Excel. That was my joke, but nobody laughed at the joke. Please tell me you laughed at the joke. It's okay. Now let's talk about massive parallel processing. SQL Server historically is a scale-up technology. What that means is, if I need to make my queries run faster, and I'm limited by hardware, I got to buy more hardware and add it to this box, or buy a new box and move the databases over. So I can add more RAM. I can add more CPU cores. I can add another CPU socket, buy a more expensive motherboard. I can get faster disk. All of this stuff adds up. And I get faster queries. Life is good until you hit a wall. There's only so much RAM you can fit in one machine. There are only so many CPU cores you can have in one machine. You could pay a whole bunch of money and get an extremely expensive device. Or you could go the other route, scale out. I'm going to buy more machines, relatively cheaper per box. The sum of 10 boxes might have more RAM than my scale-up machine. I might be able to run more queries potentially faster using that scaling out, and I'm going to do it typically at a much lower cost. Hadoop is the classic example of this kind of system. I have my Hadoop cluster, and instead of buying top-end servers, slamming in terabytes of RAM, NVMe, direct attached storage, go the whole 9 yards trying to optimize this box, I'll just get 50 or 60 relatively cheaper boxes and throw a distributable problem at them. As long as you can split the problem out and have it run concurrently, then your scale-out solution is typically going to be cheaper or faster, possibly both, than a scale-up solution. Scale-out, like I said, it's often cheaper. And you're going to hit a ceiling on scale-up long before you hit it on scale-out. I can have a Hadoop cluster with 4-digit nodes. I can have thousands of nodes. Petabytes of RAM. Probably can't dump a couple petabytes of RAM on a single machine. If you can, you have some really awesome machines. But scale-up takes that additional power. It comes at a cost of complexity. Scale-up is less complex than scale-out. Scale-out means I have some sort of coordinator, some central server. You can hear it called a driver, a name node, a head node, whatever you want to call it. This central server is your air traffic controller. It's going to coordinate work from end users who want to get stuff done, sent in to your workers, your drones who are flying around, performing calculations, collecting data, aggregating it, whatever they're doing. Air traffic control sends out messages to these drones. They're flying around. The drones independently operate. They send their data back. And air traffic control comes back to the end user and says, hey, here's your end result. That level of complexity means more things break. You have more potential points of failure. You also have a lot of potential points of failure in those workers, those drones, because one of them may start doing work and then just explode. Hopefully your server doesn't literally explode, but conceptually it exploded. If that happens, you don't want the whole thing to fail because 1 out of 60 machines failed. You just want to have a more resilient system where another machine is available and is able to pick up that slack. But that's more complexity. That's more work, that's more code around the problem. There's also typically a longer startup time. If you're talking millisecond queries, a Hadoop cluster, a Spark cluster, generally is going to be slower. There's time that it takes to coordinate. That time it takes to coordinate can be as much as a couple of minutes. Meaning that if your queries need to be in a second, this is a scale-out solution is not necessarily your best choice. But if you're working with larger batch data, a scale-out solution is typically going to give you a better result because if you can distribute the problem across 100 servers, each server finishes in just over 100th of the time. So you get that almost linear scale-out. So that's the concept behind massive parallel processing. And PolyBase is Microsoft dipping a toe into the MPP waters on-prem for like regular people who don't buy Parallel Data Warehouse or now APS. So let's talk installation. You've got a brand new copy of SQL Server 2019. You want to install PolyBase. You want to get it going. And so in our installation center, we're going to say, hey, I'm going to install a new SQL Server instance. Inside there, I have in instance features the ability to install the database engine and PolyBase query service for external data. This is what I call PolyBase v2. If you want to get that blob storage, that Hadoop interactivity, you also have to check the Java connector for HDFS sources. I just said a dirty word, but if you want to deal with Hadoop, you got to work with Java. Yes?
Why would that, if you don't know if you're going to need it or not, but you might, why wouldn't you just go ahead and install it at the same time? Why is it an option?
So why is this an option? Why not just install both sets at once? The answer is for companies that say, I really like the idea of integrating with Oracle or with SQL Server, but you install Java on my SQL Server machine and I will throttle you. For those types of companies. They probably did not literally use that term, that I'm going to throttle you if you install it, but the idea that I have to install Java on my SQL Server, it means I have to patch it like every day because it's Java. That's why. That look is why. So if you do want blob storage or Hadoop connectivity, patch it every day. Next, we have the idea of having PolyBase as a standalone solution or as part of a scale-out cluster, or a scale-out group is what they refer to it as. Here's the idea. PolyBase standalone is easier. I have it on my VM. That's how I've installed it. Because I don't need to be on a domain. I don't need to have any Active Directory accounts. I can just install it any place. But it only works for that machine. And if I have 2 instances of SQL Server, I can only install PolyBase once. It's a service. It's a machine level service. If I have 2 VMs, I can install it on each VM. So it's independent. It's on its own. As part of a scale-out group, suppose I have 5 machines. I have 1 machine that is the controller, that is the head node. I have 4 worker machines. If I install PolyBase as part of a scale-out group, I can connect those 4 worker machines to my main node and now distribute out SQL-type queries among those several machines. This is specific to PolyBase. It's only going to work for external tables. So if I have all my data, like I have a Kimball-style warehouse with some giant fact tables, I can't distribute that out among 5 servers. But If I'm pulling data from Hadoop or from a remote Kimball style server, I can have that work processed among 5 servers. So that's the big difference. Scale out groups are more complex, but that's where you're going to get your real performance benefit, because you have several machines working in concurrence in order to solve your problems.
Could you know, you have this huge table, but if it's partitioned, can you have it on different machines and farm it out that way?
Could you have data partitioned among several machines? The answer is yes, and we're going to kind of see that example tonight. Yes?
So you're going to install SQL Server, and you're installing PolyBase. So let's say you install PolyBase locally with SQL Server. If the intent is not to connect to other types of databases or to other remote nodes, what does it actually give you in addition to just SQL Server locally?
So what does PolyBase give you if you're going to install it standalone? The answer is the ability to connect to those external sources. I can connect to a Hadoop cluster, or to Blob storage, or to remote SQL Server, to Oracle. I can connect to a Spark cluster. All of that stuff I can only do, avoiding link servers, I can only do with PolyBase. So if I don't install PolyBase, but I have SQL Server, I can't really connect out. I'm avoiding link servers for a reason, because they're awful. But that is historically what we would use. We would use a link server. And as much as I'll joke about link servers, they're useful. They have their value. PolyBase has a different value proposition. In some places it's better, in some places it's worse. So since I broached the J term, this is new as of SQL Server 2019 CTP 3.2. So let me walk through this. Last year, not too many people heard about this, I think, but Microsoft partnered with a company that's called Azure Systems. I think it's how you pronounce their name. I don't know. I've only read it. I've never seen it or heard it. So we have Azure Systems. They are a distributor of Java. The reason Microsoft partnered with them is also about last year, Oracle announced that Java Standard Edition is going to be no longer like freely licensable in production environments, that you're going to have to pay Oracle money to run Java in different places. Please don't quote me on this. I'm not a licensing expert, and I probably make stuff up. That's my licensing disclaimer, by the way. Nevertheless, Oracle wants you to pay money for Java. Microsoft says, wait, we don't want customers to say, I'm not going to install PolyBase because I don't want to pay Oracle money. I mean, it's perfectly reasonable not to want to pay Oracle money. So they partner with this second distributor of Oracle. And the reason they partnered with them, instead of saying, just go install OpenJRE, the Open Java Runtime Environment, is you can install OpenJRE. That's still free. PolyBase will work with it. But your support is limited to community support. Meaning, if I have a production issue and it's due to Java, I'm going onto a forum and hope that somebody in the community is going to be able to answer my questions. If I call up Oracle, they'll say, hi, you didn't pay us. If I call up Microsoft, they'll say, it's not really our thing. So with this partnership, Microsoft is working directly with Azure Systems. If you install this version of Oracle, or this version of Java, then Microsoft has contracted out support. Meaning, I call up Microsoft and say, hey, I've got this SQL Server with PolyBase. Its Java support is failing. What's up? They can solve the problem, or they can bounce me over to Azure Systems, who offer this sort of production support. Yeah.
Based on what you're saying now, had it into the thing a moment ago, I could have misread the blog post about this particular feature. And my understanding was that it wasn't that Oracle was changing the licensing such that you had to pay to have it in production, but it wasn't supported without paying them, without having a support contract. So basically that put the main Java in the same category as what you're talking about now of purely community support, or possibly not even if the community can't update the actual Java runtime, because that's held within Oracle's control.
Yeah, so Solomon mentioned the blog post that his interpretation is that it's still available for production, Oracle SE, but that you would have to pay for support. I think they're gating installs of Java now, where you have to agree to terms to download. I had to do this recently, so I had to grab Oracle SE 1.8 not too long ago, and yeah, I know. Thank you. I appreciate your condolences. And I did have to go through some extra steps. It wasn't simply click this button to agree to our license terms and download like it has been in the past. You had to register an account, you had to log in with that account, and you had to go through additional licensing stuff. So I believe that they, again, I could be wrong, can be wrong, but I...
This was a blog post on Microsoft Tech Developer or whatever.
Right.
On this part of the release, it could have been that that just wasn't in important detail to put in that post.
Possible.
So,
Yeah.
So Unity is a development platform that builds for multiple platforms, including Android. And they're also using OpenJDK now in the latest version where it's legacy Android, depends on Java, and the newer versions depend on Kotlin.
Right.
But for the legacy people, the Unity package now includes an OpenJDK library so that you can build your own packages without using any Java from Oracle.
Yes,
So,
you...
I mean, pretty much a lot of people, not just Microsoft, are using OpenJDK as the Java alternative because of whatever Oracle's doing.
Right, OpenJDK as the Oracle Java alternative, which is funny because they're both still Oracle Java. But yeah, you can go that route, but again, you're limited to community support. The idea here is you bought SQL Server. If you have a problem related to Java in PolyBase or in machine learning services, you can call Microsoft and they'll actually support it. Versus the alternative, which is go to the community forums and find out that there was a question 3 years ago and nobody actually gave the answer. So we've got past Java. We went to see therapists. We're okay now. Life is good. We're now installing services. There are two services that install as part of PolyBase, the engine and the data movement service. The engine is your air traffic controller. It is the thing that controls all of this data processing. The data movement service is your drone. That is the thing that moves data around. It's a thing that performs some aggregations and computations, but it's not the central intelligence of PolyBase. For standalone, you see the default accounts are NT Authority Network Service, so we can't create virtual accounts for these, cannot. We can use domain accounts. For scale-out group, you must use a domain account. By the way, Tracy, if there are questions, you can...
No, there hasn't been any questions.
That's okay. Cool.
The only comment was it's kind of funny, the sound of your lip movements looks like a badly dubbed movie.
A badly dubbed movie.
That was way at the beginning,
Oh.
so it might have changed since then.
Godzilla, yes.
So I just let you go, because that was way.
Thank you. Thank you for letting me go. One thing I want to point out before installation is that you can grab a configuration file of all of this if you have to install it among several servers. I know it's an advanced DBA group, but still good to remind people that, yeah, you don't have to click next, next, next like every time for all the servers. Take that, then you can use PowerShell and automatically install over a bunch of servers.
Paul actually told me thank you for telling me that.
So things install, and everything's green. Everything's perfect because it's a demo. Well, it's actually a screenshot. That's why it's perfect. If it were a demo, it would have failed. We're installed. Next up, we have to enable PolyBase. You run spconfigure. The config setting is PolyBase enabled, and you turn it on. Just because you've installed PolyBase doesn't mean you turn it on, so you actually have to turn it on. And we also set Hadoop connectivity to 7. Hadoop connectivity, only necessary for V1, but 0 means no Hadoop connectivity. It's off. 1 through 5 are legacy settings that you should never use, because if you have a Hortonworks Data Platform 2.0 on Windows installation anywhere, then that's just a pain. So 6 is Cloudera, 7 is Hortonworks. Both of them will work for Azure Blob Storage. Considering that Cloudera and Hortonworks are merging together, I don't even know what's going to come from this. For now, I'm just setting it to 7. We're going to use Blob Storage tonight instead of Hadoop, so it doesn't matter. But after I do this, I have to restart the SQL Server service, as well as the PolyBase engine and data movement services. So I've restarted it. Then, if I want to install drivers, generic drivers, maybe a Spark driver, a Hive driver, I have to go grab them myself. These are not provided as part of the SQL Server installation. The things that are provided, connector for SQL Server, for Oracle, for Teradata, and for MongoDB. All other connectors, you're on your own. So, for example, I may grab, by the way, all the slides are available, so you don't have to, you can still take shots, I'm happy with that, but I'll give you the slides at the end. Here we have Hortonworks Hive ODBC driver, and I want to install it. It's all just next, next, next. This was the only screenshot I could take of it because it was so fast to install. So I wanted to get it in progress. I didn't get any progress. But I can go to ODBC data sources, and in ODBC data sources, I can set up my Hive or Spark connections. So for example, I have a Hadoop cluster at home. It is called Clusterino. Listening on port 10,000 is Hive 2. Hive server, I have a username and password, and I go and hit test, and hey, I connected to the data source. This shows that my driver is installed. It shows that my Hadoop server is cluster is running. Hive is available. I can connect to it. Then I can bring it into PolyBase. Same concept with Spark. If you're using Spark on a Hortonworks data platform cluster, that's port 10016. That's a thrift server, and you'll connect to that. So we've installed it. Now what? We actually want to do stuff with it, I guess. So let's talk about the stuff we can do with it, I guess. There are three sorts of external objects that are relevant to us. The first is external data sources. An external data source, it's just what it sounds like. It's basically saying there is some data somewhere in the world. It's called Oracle. Here's where it lives. When I say Oracle, I mean this server right over here, and it's going to use this driver, and that's how. And we'll use these credentials to connect to it. That's all an external data source is. So I have an external data source as an example. We use the syntax create external data source, and then I named it because that's my Hadoop cluster. So I made it clear to me. The type is Hadoop. If you're using Hadoop, you'll say type equals Hadoop. If you're using Blob storage, you'll say type equals Hadoop. If you're using something else, you'll see what we do. The location. Where does the data actually live? It doesn't live in SQL Server or in my SQL Server. It lives somewhere else. It's an external source. So here, the data lives on Clusterino, in my cluster. You can get to it via port 8020 over the HDFS protocol. So over on the name node, I have exposed port 8020, and that's how I can connect in and grab data via HDFS. In addition, specifically for Hadoop and only for Hadoop, we have this idea of a resource manager. This is Yarn, the resource negotiator. It lives on my name node, port 8050 in this case. Yarn is going to be important if I want to run a MapReduce job. So if I have a query that I'd like to run from SQL Server, but I don't want SQL Server to pull in all of the data and do all the dirty work itself. I want to offload that work onto my Hadoop cluster. I can write a MapReduce job, but I want to write a T-SQL statement instead of a bunch of Java to do a MapReduce job. So built into PolyBase is this concept of generating MapReduce jobs from a T-SQL statement. I write the statement, I execute, the PolyBase engine generates the job, it generates a jar file, ships it over to the Hadoop cluster, figures out all the details over there. That cluster churns, sends some data back to my PolyBase server. PolyBase server takes the data, maybe does some final processing, and sends it back to me. As a developer, I don't care where that data came from. I don't care what steps it went through. I wrote a T-SQL statement, I got data back, I'm happy. It took 3 hours because it's a Hadoop cluster, but I got it back. So let's say I want to connect to something else, like another SQL Server instance. Well, if I want to connect to SQL Server, I probably have to authenticate against it. So I need to create a database scope credential. Lives only in this database for PolyBase, everything is database focused. We don't really have server level objects, we have database level objects. So I have a database level credential that is going to connect to my SQL Win10 box using the identity PolyBase user and the password of something else. As of right now, this could change. It's still in CTP. As of right now, all of these V2 sources do not use Kerberos, do not use Windows authentication. So I cannot connect to SQL Server via Windows authentication using PolyBase. I can with linked servers. Hopefully, I will be able to do that with PolyBase. As of today, I can only use SQL authentication. So I'm going to create an external data source that's going to live on SQL Server / // SQL Win10. This is how PolyBase knows that it's connecting to a SQL Server instead of an Oracle server or a Mongo server. So the concept of that protocol is sort of a V2 thing, but this is how we separate out where we're connecting to. And then I just give it the name or IP address of where I'm connecting. I have the ability to turn on or off predicate pushdown. Predicate pushdown is kind of what I was talking about with that Hadoop job, where I want that remote server to do the dirty work. I want it to do filtering, to do aggregation, to do processing. Let it burn its CPU instead of me burning mine. It also means less data transiting over the wire, hopefully, because if I filter over here, a row I filter out is a row that doesn't cross the network. If it doesn't cross the network, I probably get my results faster. And I tell it, hey, use these credentials. If I want to connect to a Spark cluster, similar idea. I'm going to send in a username and password, so I create another database scope credential. And my external source says, I know that this thing lives on a server called Clusterino, and we're going to connect via generic ODBC driver. Don't know what it is. I'll tell you what it is in a moment. But we're going to connect on port 10,016. What is it? Well, it's using the driver, the Hortonworks Spark ODBC driver. And then I send in additional settings for the connection settings, like the host, the port, the database. You might say, those of you with eagle eyes, didn't I just tell you that? The answer is yes. Yes, you did. And by the way, you're going to tell me again. I couldn't get a Spark cluster to work otherwise, so I had to put in Clusterino and port 10,016 3 times in order to get it to work. But once you fill it in all the spots, it works.
And all 3 have to match.
Yes, all 3 should match. If they don't match, I did not try, admittedly, I did not try when they don't match, but I expected failure. And missing parts of them still caused failure. So I'm pretty sure they all have to match. But I did not purposefully say like port 10,015 for one of these. I'm going to connect using Spark credentials. I'm going to say, yes, I would like to burn my Spark hours instead of my SQL Server hours. So that's an external data source. Somewhere, somebody has data that I want. External file formats. Somebody somewhere has a flat file that I want. Either a delimited file, object row columnar file, ORC or ORC, I'm going to call it ORC, or Parquet file. ORC and Parquet are columnar data, really good for aggregation, really good for calculating across a lot of rows, not as good for reading across row store style. So just like a column store table in SQL Server, column store index. None of the V2 sources need this. This is only for Hadoop and Azure Blob storage. All the ODBC stuff has structured data. We have a structure of the data already. We're already dealing with tables, whether that's a SQL Server table, an Oracle table, or a Spark data frame. Still, if I'm dealing with blob storage, I probably want to create an external file format, like a CSV file format, which is delimited. So I've delimited text. Fixed width files are not supported in PolyBase. So if you've got, like, you're building your 835s currently in a COBOL-based mainframe and you're bringing them out, you're not going to be able to read an 835 in a PolyBase. I'm just going to cry for 20 seconds right now because I'm now remembering all the horrible things I had to do with 835s. Don't mind me. So format options. This is a comma delimited file. I can make it semicolons, tabs, pipes, tildes. I can do whatever terminator I want, as long as it's a single terminator type. So I could do pipe, pipe, tilde, but I could not make the next terminator a tilde, pipe, pipe. It's just got just one. Do I want defaults? If I don't have a value in between these, should I fill in a default, like a 0 for a number or an empty string for a string? Right now, this is true. So yes, I will fill in a default. If that's set to false, it'll just be nulls. If I have a string delimiter, I can include it. But PolyBase is kind of stupid about string delimiters because it will not allow you to escape the same character within your string. So if I have quotation mark as my string delimiter, and then I have a quotation mark inside my string, it doesn't matter if you double it up, doesn't matter if you put a backslash, doesn't matter what you put before it, that will actually break the string because it'll find, oh, I found another delimiter. Hey, wait, what's this extra stuff? And cause your row to fail. Encoding supported UTF-8, UTF-16. If you have an ASCII file, UTF-8's fine. That's the default. External file formats for ORC. Not too many options. You say, hey, this is an ORC file, or it's a Parquet file. You can set whether you want this to be compressed using a default codec or using Snappy from Google. Those are really your only options. So these are a lot easier to deal with. So I have external file formats. I have external data sources. I now want to tell the world I know what the data is. I'm going to create a table, an external table. So I'm going to create an external table using create external table. Two-part naming. It's not a linked server. I'm not using 4 parts. I'm not naming the server. Just a regular table name. Regular table columns. Nothing special here. This is all just standard T-SQL. This is all really weird stuff. So here's where it does get a little fancy, a little freaky. Where does my data live? It lives here in a folder. So /polybase data /NYC parking tickets ORC. That's where my data is living. It lives on this data source, my Hadoop cluster. You can get to it as an ORC file format, so it's in that file format. And we can reject queries if we have, or we can reject rows and we can fail queries. So going from an unstructured data set to a structured data set incurs the risk of failure. Restructuring data can cause failure in rows. When that happens, PolyBase just rejects the row. So if it can't convert your string to an int, throws away that row. And once we meet a certain threshold, PolyBase will just out and out reject the query. Say, well, we failed. Clearly, something is wrong with your data or something is wrong with your table structure. We control 3 knobs. They are reject type, reject value, reject sample value. So the rejection type, it can be a value or a percentage. In number of rows failed or in % of rows have failed. And reject sample is best if I give you a table as an example. So reject sample is really something you only do with percentages. If we say we reject at 20% failure, that 20% is cumulative. And samples are after every 5,000 rows in this example, we are going to test again, see how many rows have failed cumulatively. And if we hit 20% cumulative failure rate, goodbye. So in our first case, 15% of rows failed, so we're going to continue. In the second case, you'll notice actually more than 20% failed, but the cumulative rate, 1,850 out of 10,000 rows. So it's still under 20% total. So we continue. The next batch of rows pushes us over 20% failure rate, so we fail the query. This is a performance optimization so that you're not trying to recalculate after every row, so that when you hit 20% you fail. And also so that if the first row failed, but the next 4,999 were good, after that first row you don't say, oh, I have a 100% failure rate and just die. So this is to help that scenario as well. Yes?
What does cumulative mean?
Cumulative summation. So we sum up the totals. Instead of saying the batch percent being 20, the total percentage. So 750 plus 1,100 is 1,850. over 5,000 plus 5,000, 10,000, 18.5% of 10,000. 1850 plus 1,500 over 15,000. So we're doing that aggregated percentage instead of the percent of the 5,000 rows. So I want to create an external table. My syntax looks kind of normal. I have some columns, but columns have to be defined exactly as they are in my source. Meaning, this is actually from a SQL Server, by the way. So, meaning, on my remote SQL Server instance, I need to have a column called summons number. It has to be varchar. It has to be 50 bytes, or 50 bytes. I cannot have summons NO and then fix it in post-production over here. It's got to be exact. Names have to match. Data types have to match. Order doesn't have to match anymore. It used to have to match, but it no longer needs to match. The columns, though, if I have a column over here, it must exist in exactly the same form over there.
When a query fails, does it roll back all batches or just this batch?
So when a query fails, does it roll back everything? Yes, it will fail everything. Management Studio will not show you any of those rows, and that's really painful if you're 99% of the way through a few billion records. So yes, that will fail, and that will be ugly, and it will cause you to hate life for a little while. My location, my SQL Server table lives in a database called Scratch, dbo.parkingviolationslocal. So I named the server SQL Win10. Now I have to list database schema table where this stuff lives. And that's my data source of SQL control. Oh yeah, I don't need to specify anything about rejection behavior. You'll notice I don't have rejects because rejection is going from unstructured to structured data. SQL Server is already structured, and I'm forced to use the same structure. So I don't need to reject. I can't reject it. If it fits over here, it fits over there. It's just how it is. So here's an example Spark. And basically it's the same. I create an external table. I define my types. I define my structure based off of what my Apache Spark table actually has. Now, Apache Spark has data types that differ a bit from SQL Server. So there are translations. Like if I have a string column in Spark, by default, because of my driver, it's in varchar 255. So I have to define it as in varchar 255. Regardless of whether in Spark maybe it's only like 10 characters. If it was 1,000 characters, I have to change my driver to be in varchar 1,000, and I have to change this to be in varchar 1,000. My location is just a single name structure, so I could use database.name, but in the Spark external data source, we defined a database. We use default, but it's still a definition. So now, I'm going to dive into some demos.
Is PolyBase an enterprise feature?
Is PolyBase Enterprise Edition? PolyBase has some limited functionality in Standard Edition. For the fancy stuff like scale-out groups, that must be Enterprise Edition for the control node. For interactions with other servers, yeah, you can use Standard Edition as of SQL Server 2016 SP1. Okay, first, I have some basic setup that I'm going to configure.
Did I understand right? So.
You absolutely did. What's
Okay,
up?
great. So your PolyBase has to be SQL 2019, but you can talk to a SQL 2016?
So PolyBase, if you want to talk to a remote SQL Server instance, your PolyBase server must be SQL Server 2019. You may connect to at least 2012 because that's supported. My guess is you might be able to connect to older versions, but that Microsoft's not going to officially support it because why, nobody uses those versions anymore.
So I did understand. Thank you.
For the purposes of people who can't see the camera because we're on a full screen mode, I rolled my eyes pretty well.
Go back to
No, it's okay. It's okay. We're done. We're done looking at me. So I'm going to create a Scratch database. I need a database master key. I'm going to store my goodies in here, and so I'm going to use some secure key, literally. And I've enabled PolyBase already, but if I hadn't, I could run these, and then I have to restart SQL Server. So let's just run through this. Life is good. I would now like to connect to Blob storage. In order to connect to Blob storage, I need to decrypt my database master key because I'm going to create a database scoped credential. I've already created this, so I am not putting on screen my Azure Blob storage identity in secret. Sorry, people on the internet, you don't get it that easily. Because you can see if I switch over to the Scratch database that I have already got an Azure storage credential. And I'm going to show you that the number 1 means that I have one. If I didn't, I would create it right here. I am going to create an external data source called Azure North Carolina Population Blob. So you may ask, what's over an Azure North Carolina Population Blob? And I will say, that's a great question. What's over there is probably North Carolina populations in blob storage. Probably. I mean, we're going to see. We're going to find out. It's currently loading. It is possible that it's something totally different. I may have accidentally let my identity and credentials out on the internet, so we'll see what happens. Yep. Can you use a certificate instead? I'm not sure. That is something I need to look into because it does lead to a complaint of mine. We'll get to my complaint later. All right, so in here, a blob container, NCPOP. I have some census data up here. That census data is, in fact, North Carolina populations. So I'll connect to NCPOP at CS PolyBase blob. This is secured. I do need to pass in my credentials. And then I'm going to create a file format, CSV. So it's comma-separated data. And it looks like this. So North Carolina population has a few columns. I've defined those columns. Location is North Carolina population.csv inside census folder. The data source is this blob. The file format is CSV, and I reject if I have 5 or more failures. So I'm going to run this stuff now. It'll take a moment. For some of these data sources, it will, when you create an external table, validate that the structure looks okay, that the data actually exists. For others, it will just simply create the external table. There is a rhyme and a reason to it, but I'm not going to get into it here. I do a quick select star. The specific contents don't matter. I just want to show you I'm querying Azure Blob Storage. I'm pulling it into SQL Server, and I'm treating it like a regular table. To the outside world, I'm just connecting to dbo.North Carolina population. It's a table. There's nothing special to it. Within Management Studio, I have my Scratch database. But I just want to point out, I don't see it here because it's in external tables. I actually prefer the way that Azure Data Studio shows this because for Management Studio, they hide external tables in a subfolder. For Azure Data Studio, they're just regular tables, except it has the word external in parentheses after the table name.
What feature did you use to create this external table?
PolyBase. That's the whole talk.
I mean, but that's, you didn't use any, you could create external tables a lot of ways.
No, this is the only way to create external table on-prem in SQL Server. There is a concept of an external table using elastic pools in Azure SQL Database. So they do overload the term external, like external table. And that's where the type will be a little bit different from Hadoop for my external data source. So it would be something else, like elastic pool or something. It's technically not PolyBase. But if I'm on-prem, the only thing that will create external thingies is PolyBase. So I queried, I got back 13,607 rows. The reason is there's a header row in this file. Header rows cause PolyBase to fail. On-prem PolyBase does not support skipping rows. So we can't say the first row is a header. Skip it. Instead, we have to ensure that our reject value has that one padded in. There are also 3 additional rows that have a character value for the population. So those rows get rejected. Yes?
Since that need is so common across the industry, do you think that's something you're going to put in PolyBase? The bypass the header?
So is that something they'll put into PolyBase? I will tell you this. Azure SQL Data Warehouse does have that capability. But SQL Server 2019 does not have that capability. Whether they'll add it in, who knows? Hopefully. I would like them to.
Then you can never use a rejection of 1.
No, you could. You could still reject. Because you could say, you know what, I'm going to say that some of the data may just be junk. So,
I'm saying if you go to 1, then the header's always going to trigger it.
Go to 2.
right, you'd go to, so 1, yes, you'd have to go to 2. Filters. Filters work like you would expect. I have a where clause. My where clause just looks like a regular where clause. This is hopefully really boring right now. If it's exciting, then something's wrong. But I got my rows. These are the cities that have population estimates from the year 2017. Then, so that's a great question. We will dig into execution plans just slightly at the end, depending on time. But I want to show that to you now because just in case we don't have time. Execution plans show up just like linked servers do as a remote query. But there's a bit more to the remote query. If I hit properties, I'm already showing. Here we go. So we have a remote source, and then inside here, this remote query, there's a lot of extra information that will tell you about how the query ran, what it was doing, the steps it was taking.
Extra metadata is what you mean?
Yes. Yep, extra metadata.
Kevin, since this is running on-premise, query, correct me if I'm wrong, the query is being processed on-premise on the SQL instance when it came across, right?
So the query, was the query being processed on-prem as it came across? The answer is, in this case, yes, because Azure Blob Storage does not have the concept of external compute. So I need to pull that blob storage data to SQL Server. It will either store in a temp table, or it will stream the data.
Okay, but that
Just-
means, where I was going with this, that means your standard backstop and parallelism settings will still apply for this, unless there's some trick where it doesn't.
Yeah, maxstop and parallelism will still apply, yes.
So the pushdown does not apply to Azure Blob Storage.
Right, Azure Blob Storage has no pushdown because you can't push it down to anything. There's no server on the other end that's willing to take your query.
That means it's pulling all the data every time you do a query.
Yes, so it'll pull all the data every time you hit Blob Storage.
Does it cache any of it?
Does it cache data? No.
So you hit F5 a couple times,
Yes, every time I hit F5, it pulls the whole thing again,
even if there are 3 billion rows.
even if there are 3 billion rows. Don't store 3 billion rows in Blob Storage and pull them all back into PolyBase. This is a good recommendation, yes. But you're going to see a pattern in a little bit that helps. Also, if you have a Hadoop cluster and you're using that, now I can push down to the Hadoop cluster. Now I can process this data. I'm still not going to cache it. I wish that there were caching. Microsoft's answer to that is big data clusters, which is outside the scope of today's talk and isn't totally the same answer. It's a bit of a different answer. But there is no inbuilt caching mechanism. So I'm going to create a local table, the cities of the triangle, the cities of the triad. And we're going to see that this local table, we have different cities and where they're located. And I can just join together tables that are local and tables that are remote. No problem. So it pulled in, it listed that Raleigh, for example, is in the triangle, that Durham is in the triangle, Winston-Salem's in the triad. I can aggregate, just as you would expect. So a query that performs summation, it has filters, it joins to local tables, it joins to external tables. it shows that the triangle has a larger population than the triad as of 2017. Still true today. But I just walked through this. At this point, it's regular SQL. For a developer, it's just a normal table. My next source, Cosmos DB. Or was it SQL Server? Oh, it's SQL Server. Cosmos is next. All right, so I'm going to open up my database master key again. I'm going to create my credentials for SQL Server, and I'm going to connect to this IP address. Now, the reason I'm using an IP address here is that because I'm connecting to my desktop from my virtual machine, any reference to the host name actually goes to the VMware.1 address for that subnet because I'm running virtual NAT. Long way of saying that this is an ugly thing that you don't have to do in production for real. Over here, for real, you would use an actual host name because we have host names. Also, I don't even know if this is going to work because I've only tested this at home. What we're going to try, we're going to create a remote table called remote employee that reads SQL Server 2019 CTP 2.5 is on the laptop. Forensic accounting.dbo.employee. So we're going to try this. We're going to cross our fingers, and we're going to get results back. So amazingly, we actually got results. Thank you, Tracy. I appreciate that. We got some results. Those results, again, it doesn't matter what the results are. Just at this point, dbo.remoteemployee is now just a table. The fact that it lives on a different SQL server someplace else, no skin off my back.
What does the plan show?
What does the execution plan show? A remote query.
The SQL Server?
It shows a remote query, so just like a linked server connection. We'll get into what happens a little bit deeper in a little bit. Finally, Cosmos. Connect into Cosmos DB. I am going to use the MongoDB connector. This means that my Cosmos collection must use the Mongo API. Cosmos has 5 APIs. Mongo is one of them. But they've also got like Graph, SQL API, a Table API. They've got a couple of others. I have to use Mongo. I have to connect with SSL. So the connection option, SSL equals true. If I try to connect without SSL, I get an error. That's a Cosmos DB requirement. I'm going to create a table called Volcano. So Volcano is a data set that, it's actually a Microsoft sample data set, but it has, for each volcano, a pair of coordinates, latitude and longitude. I am going to create all of the pieces, and then I'll return the contents of select star. So again, every time I query this, I'm going to pay Microsoft and hit their Cosmos API. Here I can push down a predicate. Here I can force some work back on them. So it's not going to pull all the data every time. It's hopefully going to pull back a small amount of data. Oh, I will do this. So each one of these volcanoes, you'll notice the IDs duplicate because over on the right, past where I can scroll, I have coordinates. I have latitude, second, longitude, first. In the file itself, this is actually one row with an array. PolyBase will, for any Mongo connection, flatten out every array. It's going to unpivot that data, turn it into one row per array element. That's fine if you have one array. Potentially fine. I mean, here it's like this is painful because I kind of lose which one's latitude and which one's longitude. I can rebuild it mentally because I know sizes. I know the magnitudes. But in a case like this one, 34 and 38, both of them could be valid latitudes or longitudes.
You don't know the order, right? It's like SQL. You don't know that they came in the proper order.
I don't know that they came in the proper order. I actually can get that they came in the proper order because I can check them out individually. But yeah, in practice, that's painful. More painful is if I have two arrays, because it's going to unpivot both arrays and lead to a Cartesian product of those arrays. So you don't want deeply nested structures with PolyBase on Mongo. MongoDB likes deeply nested structures. PolyBase does not, because PolyBase is giving you a SQL Server table style interface to something, and you're giving it a deeply nested convoluted structure. It's going to give you a lot of rows back. So what if I want to fix this? Well, one thing that I could do is if I don't care about the coordinates themselves, I can just say distinct values. And that'll give me back one row per volcano. So perhaps I only care about the countries or the last eruptions. Then I get that data back and I'm okay. If I want to get the list, I'm going to load them into a temp table so that I don't potentially hit Cosmos a couple times, and use the string ag function in SQL Server 2017 and later to aggregate this set, comma delimited, grouped by everything except for the coordinates. And that will give me back one row per volcano with the longitude followed by the latitude. And I get my results. So that's the high-level parts of PolyBase. We're now going to talk about three specific use cases for PolyBase. The first one is cold storage of data. So here's what I mean. You've got some data. You've probably got a big table somewhere. There's a big table with a lot of data. Usually, it's date stamped. Usually, people only look at like the last 30 days, or the last 60 days, or maybe the last year. But you have to keep 7 years for auditing purposes, for compliance purposes. Or you're like a Department of Health where it has to be 99 years after a person dies. Or you could be like Medicaid where it's 7 years and you better get rid of that data after 7 years. I don't care, doesn't matter how long this period is. In actuality, people almost never look back more than a year, maybe 2 years. So you have all this data that's living in your tables. When you scan the table, you have to go through all of that older data. Well, if almost nobody ever looks at that data, but you can't get rid of it, because every once in a while an auditor comes in, or every once in a while somebody runs a query. Yep, our auditor has already arrived. So every once in a while somebody runs a query that needs 3 years of data. So I need to have it available. And thus, right now, I'm paying for this really expensive pure storage array, and I'm putting all of that data on there that's getting used once every month. What we can do instead, take that older data off, shunt it into cheaper storage. That could be blob storage, could be Hadoop, could be some other system. And when users do need the underutilized data, we just tell them, look, it's going to be a while. It's not going to be as fast as it was before. Before, we had that flash storage. But all of your other queries get faster because we're not having to scan over nearly as much data. And we can probably put more good stuff on this really expensive flash array. Maybe we had some spinning disks over here that was storing some data because we didn't have enough space for the flash to put it all on flash. Who knows? So our technique. We're going to write some data to blob storage, and we're going to use a partition view to join things back together. This is SQL Server 2000 style partitioning. We are bringing it back. The concept here is that blob storage and HDFS are both generally cheaper than what you're going to have running your SQL Server disks. It's cheaper than that SSD-based SAN. It's cheaper than NVMe. So we're keeping less data on that fancy SAN or that fancy flash array. We're putting data over here in blob storage that is rarely needed. And partitioned views means that I don't have to change any code. So let's see what this looks like. Cold storage. First things first, I must prep my server. My preparatory script. I'm I have a table called fire incidents backup. I am going to create a table called fire incidents local. So this is Wake County. Anytime the fire department responds to a call, we get a row. It's actually not a big data set, but we're going to pretend it's a huge data set. It's about 177,000 rows. So I want to build out in blob storage a fire incident blob. I'm going to take that old data, I'm going to move it into blob storage, and to do that I need to create my external data source. Locally, I'm going to keep 2019 data, 2018 data. So I create versions of those tables for those years. And it turns out that there's some data that has a dispatch date time of null. Not sure what's up with that. We could retcon some sort of answer that, oh, well, this is data that maybe it was some data that was a little dirty, but it's going to get fixed soon, I promise. Or, yeah, there was a problem in 2017 where some rows were just null, and we just have to keep it. So here, I'm just keeping it. If it's null, it goes in the null land. Each one of these tables has a check constraint. Check that the dispatch date time in here is null, or check up here the dispatch date time is between my date range. This is how we would do classic partitioned views in SQL Server 2000. So I would have those tables with check constraints. I would have a view that unions them together. With PolyBase, the story's a little different. Here's what we're doing with PolyBase. I decided to write some dynamic SQL because I did not want to have 10 copies of different years and have to copy paste that so many times. So I said from 2008 to 2017, check to see if the external table exists and drop it if it does. Just preparatory dropping. I am going to use ORC file format because it's huge amounts of data, I promise. Then we're going to store these tables in blob storage. And I've got a little $year variable that I replace in here. So I create my table. It goes into a folder, fire incidents 2011, fire incidents 2012, and so on. So we're going to create that. And yes, I know I picked the slowest possible way of iterating over this set. A while loop.
What is an ORC file?
ORC is an object row columnar. It is intended, it was designed for the Hortonworks data platform version of Hadoop. It is a column store style file format. So it's really good for aggregating, for basically taking a few columns and generating aggregates off of large numbers of rows. Okay. So next, here's another setting that I did not talk about. Allow PolyBase export. Only for V1 sources, only for blob storage and for Hadoop. V2 is read-only. I cannot insert. With V1, I can insert, but I cannot delete, I cannot update. Certainly cannot merge, but I can insert. So what I'm going to do is take each year's worth of data and insert into that year table. So I have a while loop. Let me just run this right now. So I have a while loop that I'm going through year by year. I'm inserting where the year of dispatch date time is equal to $year. Again, this is slow, but I'm taking the scenic route. I also have to insert where this is null. Then what I'm going to do is create statistics on all of the external tables. I cannot create a constraint on an external table. The reason I cannot create a constraint on an external table is that data does not live on my SQL Server. It is external. The external owner of that data may do whatever they like with it. So my external data owner can update data without informing SQL Server. And SQL Server has no way to check that constraint to guarantee that this check constraint or this default constraint or this primary key constraint is actually true. So therefore, they don't even allow you to do it. Just throws an error and says, nope, you cannot create a check constraint on an external table, or a foreign key constraint, or any type of constraint. But you can create statistics. Statistics are going to allow us to generate estimates based off of data ranges. The statistics here are going to help the optimizer, theoretically would help the optimizer realize that all of your data is between 2009-01-01 and 2009-12-31. In reality, it doesn't do that either, because it's not a guarantee, because statistics get out of date. But at least it gives the optimizer some chance of understanding the underlying data distribution. So I created stats for every one of my external tables. We'll talk more about stats in a bit. Last bit. I'm now going to rename fire incidents local to fire incidents old, and I'm going to create a view. Because a view needs to be the first operation in a batch, I need to do this in a dynamic SQL if I want both of them to exist in a transaction. I want this to be in a transaction because anybody who's trying to query the table right now, I want to block them. I want to force them to wait until I swap out the view, and then they're going to query the view without realizing that they were querying a view. This view is the union all of these tables where dispatch date time is between a range. Here is where I've taken that check constraint, and I can't put a check constraint on all of the tables, so I have to do it in the view. What does this do for us? What horror have I wrought? And here is the answer. Here is the horror that I have wrought. I can query just local data, 2018 and 2019. Let's turn on execution plans. And what I have is 2 table scans that are concatenated together because they're separate tables. I can subsequently query a blob. If I want to query that blob, what I get back is, see, I keep hitting Control-Alt, which is my designated key command for escaping so that I can use zoom it, but then it doesn't think I hit it. So I get a remote query. That remote query is hitting blob storage, pulling the data back, and then performing whatever reshaping I need to do in that compute scalar and calculations. I can even combine the two. I don't have to hit just one or the other. I can actually hit both sources. And we have remote query concatenated with table scan. So with this, I now have the ability to move that older data off while application users have no idea that I did it. There are a couple of alternatives. I could migrate the old data to blob storage and just skip the partitioned view. If I say, look, I'm just going to store the last 2 years of data in this table, and then every month or every year I'm going to ship it over to blob storage. And if you want that old data, you're going to have to query it yourself this way. You don't have to do the partition view. Or you could store all the old data in one external table and say, like Solomon's example, if I have 1 billion rows, you're going to be waiting for a while. I don't recommend that. I actually recommend breaking it up into a bunch of different folders, into different tables. Within blob storage itself, I'm going to go to visits. It actually creates multiple files. But that's not going to help you too much because it still needs to retrieve the data from all of those files as part of the table. Next scenario, ELT. Let's say you have data and you need to store it in multiple machines. Like I've got a transactional processing machine and I have a warehouse. Typically, what we do is we build a process, maybe integration services, maybe Informatica, maybe we write our own .NET code, whatever. Take the data from the source, extract, reshape that data, transform, bring it into our destination system, load, ETL. But if you have a very large amount of data, this process doesn't work as well as you'd hope. So if you have gigantic amounts of data, integration services can choke. Like if you try to put a sort operator in an integration services data flow with 1 billion rows, you're going to run out of memory. It's really cool when it runs out of memory, but that's not helpful. It's not going to get your data into the server. So for large data sets, or for very frequent moves, we have this pattern called ELT. So we extract the data from the source system, drop it into a staging table on our destination server, and then transform the data locally into our final destination. Typically less memory intensive. Most of the processing happens on our destination server. And with PolyBase, I'm just writing T-SQL. I have no intermediary integration services, no .NET, no BEML, no Informatica, nothing else. It's just T-SQL. So let's look at a demo. Now, if you're really bad with T-SQL, perhaps this is not a great solution for you, but I'm going to assume that you're good with T-SQL. I'm going to create a schema called ELT. That way, my PolyBase tables aren't in DBO. I can put them in a different schema. That's fine. Here, I'm going to create one external table for each one of my remote tables. They're all going to live in the ELT schema. So, for example, the employee table comes from my desktop server, forensicaccounting.dbo.employee. Bus comes from here. Calendar comes from the calendar table, and so on. So we create all of these external tables. What I can do with this is that I now have available to me all of these tables for my bidding. It is as though I had created all of the tables and I had created the integration services packages to pull data over to those staging tables, except that I don't have to do any of that work. You see, if I just query this table, I have the data already. By already, I mean actually when I run the query, it's going to go retrieve that data. But I can combine these together on my destination side. It's going to pull my data, filter as much as it can over here, pull the remaining data, and then do the computation work on my destination side. It's going to then allow me to insert my results into my real dimension tables or my real destination tables. I can obviously filter and say, only give me the stuff since my last load date and give me the rows that are in there since then. So with this, I've skipped the whole extract load portion, or rather I've deferred it to runtime. This is going to be slower. It will take longer to retrieve the data than if I had set up a package that runs overnight that loads this table. But the benefit is that if data updates over here, I can get it effectively in real time. Like it is as of the point when I started the query and started retrieving data. Pretty helpful. And it also means I don't have that integration services package. It can't fail, which would be the first integration services package that never failed. Alternatively, instead of creating an external table on the table itself, I could create a view on the source system. That view has all of my joins, it has all my filters, it has my complex business logic. Maybe that view is called dim customer. And then I create an external table, etl.dimCustomer. Then I can select star from dim customer. Now what I've done is I've put the heavy lifting over on the side of the remote server because it has to join all that stuff together. It can take advantage of indexes. It can take advantage of all the fact that all the remote tables are living together. Alternatively, if I have truly separate data sources that I need to combine together. I have customer data is in Salesforce. I have invoice data in Oracle. I have product data in SQL Server on a different SQL Server. I can create a set of views that join this stuff in and pull it in, again, without having to do all these integration services packages. Finally, data virtualization. Basically an extension of this last example, but I've got multiple source systems, and I want to act as though I only had one source system. And performance is not a key consideration. That is important. Performance will be worse. Guarantee it. You could write a more efficient query if all of your data is living on SQL Server than if your data is spread across a bunch of machines. But if performance is not your biggest worry, you can use external services and external tables to create that virtualization layer and pretend that everything lived in SQL Server. That way, I teach my business analysts T-SQL, and I don't have to teach them Spark SQL. I don't have to teach them PL/SQL. I don't have to teach them HiveQL. I don't have to teach them all of these other languages. And that's not bad. And when it comes to people time, again, for a business analyst, if the business analyst's query takes a few more hours, realistically a few more minutes. Let's say it takes 3 minutes instead of 2 minutes. That's not the end of the world. Just go for a longer coffee break. They're going to, or a data scientist. Actually, data science is an even better example here. It's already going to take them a while. Yeah, exactly. Go out to lunch. By the time you get back, your query's done, and you can analyze your data for the next 7 weeks. Because the amount of time you're pulling data is a lot less than the amount of time you're struggling and trying to understand why this number is 7 when it should be a 4. Yes?
Is there any, at least as you're aware of, is there any work underneath all of this where they're trying to come up with some type of indexing concept for an external source table like this?
Is there any concept of indexing the external table? The answer is no. The reason the answer is no is that underlying data can change at any point in time. The closest you get is statistics, and effectively, statistics are already kind of asynchronous point in time conceptually. Indexes are generally supposed to be accurate when we write our query. So we can't guarantee there's any sort of accuracy. Also, statistics are that much data. An index, for the original PolyBase concept of petabytes of data, even a small index can be terabytes. You may blow out your server right there. All right, so I have Volcano data. I've got a stored procedure. I would like to retrieve Volcano data. The query looks just like the one that we saw earlier for Cosmos. But our end user comes to us and says, I like that. I like it a lot, but I think it could be better. What I want to do is, first of all, let me just show you that it works. We got to show our end user that our queries actually work. They say, yeah, this is nice. This is nice. But you know what? We've got countries like China. We've got Ethiopia, the United States. What if I gave you a data set that included some information by country? Can you incorporate it in here? And the answer is, well, of course I can. Otherwise, I wouldn't show you this demo. But the person says, it's in Blob storage, and it's actually a semicolon delimited file. I say, OK, that's fine. I'm still showing you the demo. So obviously, it still works. So I create an external file format that uses a semicolon as its field terminator and does not use type defaults. So if it's missing, it's null. Here's what my country data looks like. I did have to fill this out myself. We have a lot of different features that are, I think this came from the CIA World Factbook. So I can pull this in. And my new query. Here's how radically different things look now. I do this thing called a left outer join. And then I add some columns. I mean, seriously, this is the boring part because it's just T-SQL. It's just 2 tables joining in the night. Again, please no HR comments. So I've created or altered this procedure. I would like to get volcano data. And now I know that Ethiopia has a per capita GDP of $800. Probably US purchasing power parity, probably about 2015 or so. But this obviously makes my volcano data set much better because I have extra stuff. Or, tying this back to PolyBase, I'm able to connect data from two completely different sources. One's Cosmos DB, the other's Blob storage. I could add in a third, SQL Server. I could add in a fourth, my local instance right here. I can have all of these things together. I had nothing to do with the local instance up here, by the way. It was just two tables from two different sources, neither SQL Server, connecting remotely. It's pretty cool. So let's take a couple minutes to talk about tuning in an admin. So I can create statistics, but they're not auto. No auto creation, no auto update. I have to drop and recreate these things every time. Not all external data sources support sampling either. Hadoop supports sampling because, again, if I have a petabyte worth of data over here, I can't pull in all of the data to sample it because I have to pull the data over into SQL Server to perform sampling. There is no Hadoop sampling. So I have to pull the data. I can sample. I can get 1% of the data, and then it's only hundreds of gigabytes. It's nothing, practically nothing. A remote SQL Server does not support sampling. Must be 100% full scan. V2 sources, typically full scan. Yes?
If there's no indexing on the remote data, what good does statistics do?
So if there's no indexing on the remote data sources, what good does statistics do? Statistics will help SQL Server understand whether or not it should push down a predicate. Because if those stats say that if I push this predicate down, it's only going to be 2 rows versus 2 million, I'm going to push that down. So that's what it's about. Originally, it was also, should I pull the data or should I do a MapReduce job? So it allows the optimizer to hopefully do its job a little better. It's not as powerful as having an index would be, but it's still more powerful than not having any information. Assuming that your data is, I have 1 billion rows and I have no idea how they're allocated. Yes?
So it's got to pull the data to do the statistics. Does it pull it, gather the numbers it wants and throw it away? Or does it keep it around?
So does it pull the data? What happens to that data after it's used for statistics? It goes away. It's in a temp table. Temp table goes away. Your session ends.
But it has to have it all at one time to do the statistics.
For newer sources, it needs to have all the data. It has to be a full scan. For Hadoop, you can sample, like 1% of data, 2% of data.
Can you do a show statistics?
Can you do show statistics? That is a wonderful question. And as the joke goes, the difference between a good question and a great question, or a wonderful one, is a good question is one that I know the answer to. A wonderful question is one that's actually in my demo. So I'm going to create some stats on North Carolina population, on the name. I create these statistics, and it created successfully. And now I would like to query my external statistics. If I look at sys.stats, we can see these external statistics that I've created. They just look like regular stats. They're user created. Nothing here looks like is wacky statistic that doesn't really work because they're regular stats. I can run dbcc show statistics and I can see when it was created, what the density looks like. I can see what the ranges are. They're regular statistics, just on special tables. I can create with a full scan. For Blob storage and Hadoop, I can sample. I can also create with multiple columns. But if I attempt to update statistics, they will fail. If I attempt to sample from a SQL Server or one of those other V2 sources, it says, nah, you can only do full scan. So that's stats.
But the point was, you can only create
You can only create and drop. You cannot update. You are correct. There are some dynamic management views that will be helpful for query tuning. So briefly, let's pop those up. If I would like to learn about my external sources, sys.external data sources, sys.external file formats, sys.external tables are where I need to go. So if I look at data sources, I'm going to join the database scope credentials so that you can also see so here are the sources that I've created tonight. Their locations. We can see what the type is. You can see that for my V2, it's actually none. We can see the database scope credentials that I'm using. We can even see the connection options. So SSL true, I can turn on or off pushdown. So if you're troubleshooting, you can use these DMVs to learn a little bit about what those external data sources, file formats, and tables look like. So I'll jump and show tables real fast. Do I have rejection? What's the rejected value? You can see that, like for example, my SQL Server tables have a reject value of 0. That can't reject. If I want to troubleshoot the service itself, sys.dmexec compute nodes tells you who's in my cluster. Here I have one machine in my cluster. I've got my desktop, and it is both a head node and a compute node. So it is the air traffic controller and the drone. If I had additional nodes in the scale out group, they would just show as compute nodes. There would only be one head. I want to learn about compute node status. So there's a DMV for that. That DMV has to communicate with each one of the nodes. So it can take a while and it can fail if one of the nodes is down. So here we have processes. You can see server memory, thread counts, a few other interesting details. I can check errors, so I can see why I had failures. So tonight, basically every time I shut this machine down, I'm probably going to get some failures. Here, hey, look, some idiot tried to create statistics without using full scan in SQL Server. So we can see these errors. There are a couple of other places. Whoa, no, you stay on VM. There are a couple other places where you can look at this stuff. And we have a few other DMVs too. External work shows you the queries that we ran. So like we can see, hey, this was my SQL query. This was my Azure Blob storage query. This was my Cosmos query, and so on. If you look at a particular one of these, so I'm going to order it by, actually I'll come down here to distributed requests. So we're going to order by end time, and we're going to look at the distributed requests. It will give me the list of operations that have run since the last time that I started this VM. And incidentally, distributed request DMV is its own external query, so we can see it running right now. So, all right, well, here's one for volcano data. Maybe I want to do QID 1813. I can plop that into distributed request steps. Yeah, here. I'm going to have to type. And then we run it, and we get to see how in the world we got our query working. And you can see the steps that go into this operation. We can see that, oh, there's a Hadoop round robin operation. Well, that was when we pulled data from Blob storage. So it was loaded into a temp table. We streamed from the temp table. We eventually dropped the temp table. These commands technically are kind of a lie. This is not truly the SQL that's running under the covers, but it is close enough to reality so that you can troubleshoot. And so that Microsoft can troubleshoot in the event that there's a PolyBase error. There is a bit more to this, but this is the point where I hawk my book. So I'm currently working on a book on PolyBase. Working title is PolyBase Revealed. Will be released to the public some month. Later in the year, sometime, hopefully. We'll find out. We'll find out together. But that's where you'll find out a lot more about this information on what those DMVs look like, troubleshooting for Hadoop, troubleshooting for these other sources, because trust me, I've been up here long enough tonight. So let's wrap up talking about execution plans. Blake had the question earlier, what does an execution plan look like with PolyBase? And it's a really good question. It's an excellent question. Again, using the definition of excellent question. I have pre-created some SQL plan files. We're going to load one up inside Management Studio. And so here is one of those queries. I created a table that's called parking violations. If you come down to my remote query, this is where it's showing I have a statement and there's a bunch of XML. You'll want to parse through the XML, and inside here you can start to see things like a query plan and the logical operations, so you can start to see what's actually happening inside my remote query. So let's take this, open up Notepad, drop it in, see that it is a lot of text. These plans are not trivial. There we go. Now it's really big text. More impressive that way. But basically, we can read through this XML and go insane, but also find out things like, oh, we performed a MapReduce job. External pushdown was on. Here's a logical operation for a global aggregate. So the physical operation was also a global aggregate. Kind of stuff that I'd love to see in Management Studio itself or in SQL Century 1 Plan Explorer. I did it again. Century 1 Plan Explorer, having maybe a PolyBase section. I'd love to see that. Neither of them currently does. Instead, you'd have to read through XML and go insane. Or you can go through those DMVs that I have and also go insane, but for a different reason. The V2 types, those remote queries look very similar. The structure of the XML changes a lot, but they all have this remote XML. So conceptually, you can follow along and they all kind of fit the same way. Wrapping things up tonight. PolyBase has got a lot of what I consider really good business use cases. We covered 3 of them tonight. Cold storage, replacing your ETL jobs using ELT and deferred, I'll call it deferred translation. And then also our third case of proper data virtualization. If you want a SQL interface, you're not that concerned about performance, you're okay with it being a little slower than it would be if everything were native, PolyBase is a really good option. 2019 edition. At this point, I probably would say, unless you have a Hadoop cluster and you need PolyBase for 2016 or 2017, don't worry about it. Wait until 2019. You'll get the additional data sources. Life will be so much better. If you would like to learn more, if you want to grab these slides, you want to grab my demos, links to additional resources I still need to update for 2019. I have an older version of it. csmore.info/on/polybase. If you have any questions at all, please feel free to reach out to me. Email address, Twitter handle. Thanks, everybody. So Was this recorded? I hope so. So this is live streamed. I'm going to go. No, start recording is for local recording. So Twitch also stores these. I'm going to make sure that it stored the video. If it did store the video successfully and I don't look like a complete dope, then I'm going to post it on YouTube as well. In post-production, I may not look like a complete dope. We'll find out. But yeah, I'll try to post it on YouTube afterwards if the video recording worked out. If it didn't, then no, it was Twitch holds onto these for up to 14 days, and then they delete them from their servers. So again, once we go offline, hopefully everything's stored, everything's looking good. But this is the first time that I've done this, so we'll find out. Any other questions? Yeah.
So I'm reading some documentation and it says, in PolyBase we can use the pushdown to improve performance in a query for the external table. Mostly we use this feature for the scale-out cluster cases. So what does that exactly mean? What's the difference again? When would you want to use a scale-out cluster case?
So the difference between a scale-out cluster and a standalone installation is that a scale-out cluster has multiple SQL Server instances. The benefit to having multiple SQL Server installations, multiple machines, is that if I have a distributed query on the other side, so I've got, let's say I have a Hadoop cluster, and I have 10 data nodes over on the Hadoop side. If I have 10 SQL servers ready to accept that data, each one can kind of buddy up, and now each SQL server is doing 1/10 of the work. If I'm aggregating that data, I'm doing more work in that temp table, then those 10 servers can do that concurrently and join everything back together at the end. This also works for other sources, not just Hadoop. And I have seen some nice benefits from having a scale-out group, even one as small as 3 nodes. Bigger scale-out groups tend to be a bit better, but even if it's as small as 3 nodes, you see advantages in performance. Any other questions? Great. Well, in that case, I'm going to turn off the audio. We're going to shut down the recording. Thanks to everybody who came into our inaugural Twitch stream. Next week, Andy Leonard will be talking to us about Azure Data Factory, another ELT-style solution, and he will also be on Twitch. So come back next week.